Hey guys, welcome to Intellipaat. Machine learning, possibly one of the hottest field. You've got a complicated problem, you need a machine learning solution for it. But that solution, it needs to be extremely reliable and it needs to be high on accuracy as well. But the question is, how do you build a model that will solve your problem and will be high on accuracy, given that there are so many parameters out there to choose from when it comes to training your model? This is where hyperparameter tuning comes into picture. It allows us to choose the correct parameter to get the best accuracy score for a model out there. Before we get started, don't forget to subscribe to Intellipaat's YouTube channel and do hit on that bell icon so you never miss out on any of our latest updates. Now let me walk you through the agenda for this video. Firstly, we will be talking about hyperparameter tuning, its basics. Thereafter, we will look into two types of hyperparameter tuning, namely grid search and random search. Further, we will be looking into the differences between grid search algorithm and random search algorithm. And finally, we will learn how to use hyperparameter tuning to get the best accuracy on a support vector machine model. After going through this video, we hope you would have a solid foundational understanding about what is hyperparameter tuning and how to get started with it. Also guys, if you want to become a certified professional in Python for data science, Intellipaat offers a complete course in the same, the links for which are given in the description box below. Check it out. We hope the agenda was clear to you. Now without further ado, let's start the session.
Hyperparameter tuning, as the name sounds, is used to tune the hyperparameters of a model to make it increase its accuracy. So what are hyperparameters? So for instance, let's take the support vector machine model as an example. Now, when you're training a support vector machine, you need to set a lot of parameters. These parameters determine how your machine learning model will get trained, for how long it will get trained, and how it will begin with the training session, and how the training session will go on, and how long it will go on. So these are the kind of things that the hyperparameters are responsible for. To give you a quick look, let's take a look at the sklearn libraries documentation for support vector machine. This is the support vector classifier, also called SVC, and as you can see, there are these many parameters that you need to change. Now, as you can see that these are the default parameters, and you can take a look at all the options that you can take. So for instance, the parameter named C, parameter named kernel, you could say the default is RVF, but you could change it to poly or sigmoid or pre-computed or any other value. As you can see, there's also degree, there's also gamma, and there are a lot of other parameters that you can set. Now these parameters are responsible for you to understand how your model works, and these parameters also take care of how your model will take care of the data interaction, and how it will train itself and figure out the classification problem. For instance, if you have a data set and you want to use it to classify your algorithm, to train it on a classification problem, this algorithm, if you don't set any of these parameters, these are the default parameters that will get set automatically, and all you would have to do is train your model and you will get some sort of an accuracy. It might not be the best accuracy you get, but it will be the accuracy you get by the default parameter. So if you're not satisfied with the accuracy that you have with any of the models that you have trained, one thing that you can do is called hyperparameter tuning. That is, you could change the parameters to different values and see how it affects the accuracy of your algorithm or the trained model. So for instance, if you have trained model with the default parameters and you change it and you get a better result in the accuracy score, that means that that model is better than the previous model and you need to pick that model. Now all of that is good, but since you can see that there are so many parameters that you need to think about, and what's even more difficult to understand is that since there are so many parameters and all these parameters have so many options, which ones do you choose and how do you go about choosing one of those? Now, since machine learning is based on statistics, probability, and calculus, there's no fixed answer. There's no way to determine which one to choose right off the bat. So if you want to learn how to choose one, you need to try a lot of combinations. Now this is where the hyperparameter tuning part comes in. So in hyperparameter tuning, what we do is we take a list of all the possible or all the options for the hyperparameters that we are choosing, and we choose a lot of combinations in those hyperparameters, and then we pick the ones that lead us with the best result. So to give you an example, since in SVC, let's say these are the parameters that we're concerned with: C, kernel, and gamma. As you saw in the documentation, C, kernel, degree, gamma, all of these are parameters that you could set to the different values, and you might get better or worse results depending on how your data set. Now the thing is that there's no fixed answer that you choose these parameters together and you will get the best answer. A lot of it is based on experimentation, so you would have to pick a lot of parameters and do this. So the two options that we have to do this are called random search and grid search.
Just a quick info guys, if you want to become a certified professional in Python for data science, Intellipaat offers a complete course in the same, which covers all the major concepts. Don't forget to check out the link in the description box below. Now let's continue with the session.
So we have a grid search algorithm and we have a random search algorithm. So what do these mean? Well, let's say that these are the options that we want to test our or tune our hyperparameter on. We want a combination out of these options and we want the one which gives us the best result. So let's say we have a data set and we train our model on default parameters. Now, if you take a look at the documentation, the default parameter for C is 1.0. Here it is, 1.0, which is this. The default parameter for kernel is RBF, which is this one, and the default parameter for gamma is scale. However, the options you could choose a numeric option as well, and this will give you different results. As you can see, it says here if gamma is scale, the default value is supposed to be this. If auto uses 1 by n features, when 1 by n underscore feature, n underscore feature means that we have n underscore feature means the number of features or the number of columns. So if we set it to auto, then it will automatically determine the scale. However, we can pass in the scale as what we want as well. So if we want our model to be trained to its max accuracy considering all these parameters, one thing that we can do is we try all the combinations or all the different permutations and combinations of these options. So let's say we start with 1 linear and 0.1. We get the accuracy of, let's say, 68%. Then we go with 1 linear and 0.2 and we get the accuracy of 69%. Then we go with the accuracy of 1, we go with the parameters 1 linear and 0.3. So C will be set to 1, kernel will be set to linear, gamma will be set to 0.3, and we will again train the model and test the model and figure out its accuracy the normal way we do. Let's say we get the accuracy of 58%, and we try it for all the possible combinations. So we, after getting through all of the gammas, we go from 1 RBF and we train on all of these. Then we go through with this process again with 10, with 100, 1000, and we try out all the combinations. Now, when we do that, we keep track of the combination that gave us the highest accuracy. So if the highest accuracy we got was 88% with the parameters as 1 linear and 0.6, then we'll choose that. So this is what grid search algorithm does. Now, as you can see that this could be an exhaustive search. We're trying all the possible combinations and permutations. And the real problem here is that since we're trying all of the permutations and combinations, and if the data set is large, then training it will take a lot of time. And to be fair, hyperparameter tuning does take a lot of time. So if you don't want to spend a lot of time or you don't have the resources to train such all of the combinations or to try out all the combinations on the size of the data set that you have, you could try random search. Now, random search, as the name sounds, is that it chooses values at random. So it might choose 1 linear 0.4, 1000 RBF 0.2, so on and so forth. And it randomly chooses these values and picks the best one that it gets after a number of iterations. Now, these number of iterations is unknown to us because it's implemented in the algorithm. We don't have any control over that, and that's how that works. Now, intuitively, you might think that since it's randomly selecting these things and there could be number of possibilities, we might not get the best answer. And you're right, we might not get the best absolute result when we're choosing random search CV or the random search hyperparameter tuning. But the thing is, even if we don't get the best, we'll get somewhere around the best. So let's say the best attainable score using these hyperparameters was 95%. We would get somewhere around 88 to 93%. Now, this is, by the way, mathematically proven. There's a research paper on this as well. I don't know the link of this, but you can search it online and it will show you that random search CV performs much better on large data sets, mainly because it's not exhaustively trying to find out all possible permutations and combinations and trying to figure out how to get things done. So if you don't have the luxury of having large computational resources, or you don't want to spend a lot of time on training your model, you could choose random search CV, but with the understanding that random search CV might not give you the best, most optimum result that you want.
Just a quick info guys, if you want to become a certified professional in Python for data science, Intellipaat offers a complete course in the same, which covers all the major concepts. Don't forget to check out the link in the description box below. Now let's continue with the session.
But it'll give you somewhere around that. So that's good enough. Now that's done, we can understand that these two techniques are quite different. One focuses on a lot of time. So grid search will take a lot of time, but will give you a great result or the most optimum result attainable using the hyperparameter grid that you give it. And one is a little pragmatic. It might not search all the possible permutations and combinations, but it will do good enough and give you a good result. So you can try that as well. Now, this mainly depends on the size of your team, the resources that you have, the size of the data set that you have, and a combination of all of that will determine which algorithm you choose. Now, for instance, if you have if you're training your model on a cloud computing platform, let's say the Azure ML Studio, that these studios have other algorithms as well. So I don't remember the name of those algorithms, but they are there as well, and you just have to change some settings and click a few buttons, and you'll get good results. Also, they allow you to write code to do that as well, so you could read through the documentation of their SDK and then provide you with that as well. But for normal tasks, if you're doing it on your PC, or even if you're offloading these computations to a cloud computing cluster, these tasks are better performed, and grid search and random search will give you good results. So if you are using a service like the Amazon SageMaker or the Azure, I think ML Studio is called, Machine Learning Studio. So you could use those technologies, and they depending on the data set and the technology you're using, it will give you some graphical tools as well to train or hyperparameter tune your model. So, and again, they give you options to save that model, deploy it, create a web service out of it, all of that using a graphical. So if you want to take advantage of that, you could use cloud computing for that as well. But if you just want to train a model on your local computer, grid search CV and random search CV are great examples for that. So you could use that as well. So as we have seen, grid search CV will try out all popular or all the possible permutations and combinations of all the options that you've given it. Do make sure that it will only try out the permutation and combination of all the options that you have given it. So for instance, for C, it won't try out 1, then 2, then 3, then 4, then 5 to 1000, because we are only allowing it to use a value out of these four for C. And similarly for kernel, it will only try out either linear or RBF. Similarly for gamma, it will only try out 0.1 to 0.9. So that's how it's supposed to work, and that's how it does work. Now that that's done, let's take a look at the code and understand how to get it done. So we'll be using a support vector classifier, and we'll be using a data set that we have. The data set is quite small, as I'll show you, but first let's import pandas. So pandas is used to load data and data sets from our local computers or any other format using CSV, XLS, and so on and so forth. And it's loaded. Now let me load it and read CSV. The name of the file that we'll be using is called dataset.csv, or no, data.csv. So I type data.csv and the file is loaded. Let's take a look at the file, shall we? I think that's too much information. Let me just take a look at the head of the file. Head will determine the first 5. Okay, so this is the data set. Here's the user ID, here's the gender, here's the age, here's the estimated salary, and here's the purchased. So these are the, you can think of it as the records from a store, and this is a record for a particular product. So let's say it's the record for an iPhone. So these are the user IDs and the information stored about the person's name, person's gender, age, and estimated salary, and we check whether the person has bought this or not bought this. So 0 tells you that okay, the person did not buy the iPhone, and 1 would determine that the person did buy iPhone. So this is what the dataset looks like, and we'll be training a support vector classifier using a SVC, and we'll be using the support vector classifier that is provided inside the sklearn library, and we'll take a look at how to tune it using the grid search and the random search algorithm. So let's start doing that. Let's first import. Okay, I will be using now. By the way, sklearn comes with all of these pre-installed, and if you don't know how to use them, we do provide courses on that as well, so you could take a look at that. But I won't be teaching you how SVC works internally, but I'll show you how to get it done in the Python Jupyter notebooks, and you can understand how to do hyperparameter tuning, since this is the goal of this session.
Just a quick info guys, if you want to become a certified professional in Python for data science, Intellipaat offers a complete course in the same, which covers all the major concepts. Don't forget to check out the link in the description box below. Now let's continue with the session.
So let's take a look at that. So we'll go from sklearn.svm import svc. SVC stands for support vector classifier, and since this is a classification problem, a classification problem mainly means that we're trying to figure out the output in categorical format. So we don't have a continuous format where we are trying to figure out whether we have only two labels. Let's say the customer will either buy the product or won't buy the product. So if we have a limited number of outcomes, that's what's known as classification problem. Regression problem basically means that we're trying to predict something, and predictions could have an innumerable number of outcomes. So let's say that I'm trying to figure out the price of a house. That would depend on the house, and you can't keep it in a category that it will be this much. Let's say it's a continuous number. It could be 1,000, 10,000, millions, or possibly billions as well, or 1,000,000, 11,000, something like that. So it works like that as well. So since we are using machine learning, we'll use the train test split function in the sklearn model or the sklearn module. So from sklearn dot model selection, I think it's called. Oh, my sklearn app. So model selection, we import train test split, and we also import the grid search algorithm ware, and it gets imported. I usually like to import everything that I wish to use in a particular notebook at the top cell, so the cell which is at the top. Now that that's done, let's take a look at how we're going to do it. So for this classification problem, we'll be taking a look at the age and the estimated salary. We are discounting the gender and the user ID because these, in our opinion, does not have any effect on how the person whether the person buys something or not. So let's split the data into X and Y columns. X is the data that we will have, and Y will be the data that we will try to predict. So we will extract the age and the estimated salary from the data set that we just loaded from the data.csv file. And since we're using pandas, we could use the ilog. Now ilog, for those of you who don't know, ilog stands for integer location. Basically, we pass in an integer list which slices up the data and gives us only the subparts or subrecords of the entire data set that we want. So we want all the rows, however we only want age and estimated salary. So 0, 1, 2, 3. In pandas, the columns start from the 0th index. So user ID is the 0th index, gender is the first index, age is the second index, estimated salary is the third index, and we want age and estimated salary, so we want 2. And Y is the column that we're trying to predict. So we are trying to predict the purchased column. For that, we will be using, again, ilog will be used, but here we only have to pass the, I'll just copy it and I'll show you. I don't have to pass in a list since I'm not choosing multiple columns. All I have to do is press enter, and now the data set is split. Now I have age and estimated salary in one data field, and Y would contain whether the customer has purchased or not purchased. As you can see, we have it here as well. So now that that's done, quick sanity check. Let's take a look at the size of the data set that we have. So data. So So you can take a look at all the columns that we have. What are the data types of each of the columns? And finally, we have 400 entries. So the index ranges from 0 to 399. As I've already told you that in pandas, the indexes start from 0. So this is what it looks like. Let's change it back to head so we have an idea of what our data set looks like. I misspelled it. So this is what it looks like. And let's remove that. So now that that's done, the first part we'll do is we'll train a support vector classification model. To do that, we will just train test split our algorithm. And since we've already split the data set into X and Y columns, we'll be taking a look at that. So let's name our functions X train test, Y train, and we will use the train test split method to do that, and we will use the train test split method. So for train test split, all we have to do is use the X and Y methods. So we pass in the X and Y columns, and then finally all we have to do is specify we have to specify what the name of the train test size. So if the testing size is 0.25, let's say test. So now the dataset is split. Let's take a look at the size of the dataset that we have. Strain shape. So we have 300 records in the X train, and for X test we have 100. So as you can see, we have split the dataset into 25 and 25 and 100% of the dataset. So now let's take a look. So let's take a look at that. Now that that's done, we have split the dataset, and now all we have to do is train our model. We'll be using the SVC algorithm as I've already discussed. So for that, all I have to do is use the SVC, and I will use the default methods. So it's done, and all I have to do now is fit the dataset. So to fit it, all I have to do is pass in the training parameters. So we are training it, the X value, the Y value, and these are, as I've already told you, the default parameters. Check it with the documentation. All of this is completely as it was supposed to be inside the documentation. Now that that's done, let's take a look at how our model is performing. We will make a prediction with dot predict, and we will use the X test. So the predictions are made. Now we have to take a look at whether those predictions are right or not. Now these predictions can be taken using the S, or the accuracy could be checked using the sklearn package. We'll use sklearn dot metrics, and we will import accuracy score. If you've not worked with accuracy score before, so now we're taking a look at the accuracy score. We have the white train, the training. Okay. Okay. White train, it's white test, and it's done. So right now, as you can see, the accuracy is only 0.58%, and it's very, very bad. So now let's take a look at how we can use the grid search algorithm and get better score. So we have already imported the grid search algorithm, so it won't take a lot of time for us to get started with it. All we have to do is first create a grid of all the possible values and all the possible parameters that we want to tune it to. So we will create a grid using a dictionary in Python. So I will call it a grid. I will create a dictionary, as you can see, and inside that dictionary I will create some so key would be the name of the parameter, and the values would be an array of list of all the possible values that we want it to work on. So for C, I want it to work on, I think, from 1, 10, 100 and 1000. So let's do that. So 1, 10, 100, 1000. Similarly, there are other parameters that I want it to be trained on as well. One of those parameters is the kernel. And you can take a, if you want to figure out how these parameters are being chosen, you can take a look at the documentation, and it will tell you what are all the parameters that you could use. So we use kernel. Inside the kernel, I would use RBF. RBF is used by default used in the SVC, and I will use something called linear, LINEAR. So we are using RBF as well as the linear kernels. And now finally I will use gamma, GAMMA. And for that the list would go from 0.1 to 0.9. So I will So let's take, if I've not made any mistakes, it works, and yeah, it works. So now all I have to do is create a new instance of the grid search CV class that I imported above, passing a new support vector classifier that has not been trained on anything, and the grid search will take a look at the rest of it. So to do that, all I have to do is firstly create grid search CV. Grid search CV. Inside this, I will take a look, I will pass in the parameters. Now, the first parameter would be the classifier that I want to use, or an instance of the classifier. I can't use CLF mainly because it's already been trained and it won't be trained again. So to do, I have to pass in a fresh classifier. Now I have done that. Now what I have to pass in is the grid that I created, and it's called, I believe, param grid, and I've called it grid, so I am passing it in. Next, I want to pass in the scoring method. So what is it that I want to score it on? So scoring would be, I want to score it using the accuracy. So there are different parameters for, let's say that you are using it to train a, not a classifier, but a regressor. So regressors usually use something called R2 score, or the R squared score, in which we are trying to reduce the error. So it's not concerned with the accuracy, but the error produced by the regressor. So we can choose that. And now that that's done, let's take a look at it. And it's created. Now it's created, but we have to fit it. Fit it basically means that the algorithm will be run on the data that we pass in. So grid search CV dot, and we pass in the same data that we passed to train our model, and we pass in the training data, and it will take some time, guys, because as I've already told you that there is a lot and lot of options that, or a lot of combinations that it could take. So it will build up all of this and it will take some time. So let's wait for it to finish. So as you can see, it's taking a lot of time. Just wait for a few minutes. We'll see if it works. Most probably it will. If it doesn't, then we'll have to tweak some parameters as well. This is the problem with grid search, that it takes a lot of time. So you do have to wait for quite some while. Okay guys, so it is taking a lot of time. So what I'll do is I'll interrupt the kernel and I'll restart it. And since it's taking a lot of time, what I'll do is I will rescale the data and make some changes. And this will show you how this works. So let's take a look at that. Rescaling the data will make our data a little smaller, or the magnitude of our data a little smaller, and it will allow us to work perfectly with the configuration that we have. So it won't take a lot of time. So let's see how that works. So I will rescale the data. Hang on a bit. And if you ever come across a problem like this, you can rescore. You could use other functionalities as well. I'll be using the sklearn pre-processing standard scaler. You could use other methods as well. So sklearn dot pre-processing. Yeah. Import, rerun it. Works. Rerun it again. This is done. I will remove it since it's taking a lot of time, and I will rerun it again because I've closed the kernel. So run again. Now, as you've already seen, I will firstly insert a new cell below, and I will try to rescale the data. And for that, we will use the same standard scaler that we have used right now. All I have to do is create a new method. Scalar is equals to standard scalar. This is the instance of the scalar that we'll be using, and we will be scaling the xtrain and the xtest variables. So xtrain is equals to we will be using the scalar to fit and transform. Now it's going to take some time, so hang on a second. I think it's doing this because we have not run it here. So I'll just type it in and we will fit it. Let me create a new variable, scaled. And here I won't be using the fit and transform, I will just use the fit. Now the difference between fit, transform and fit is there are a lot of internal variables that need to be set for the scalar to fit the data, because it depends on the mean and the standard deviation of the data. So it takes the xtrain method, xtrain variables, or the variables inside the xtrain data frame. It will fit itself and it will and then transform the data based on the variables that it's set on the xtrain data. So I would be using x test here, and now that it's done, let me just use the xtrain scaled and the y train. Oh, I don't have to use the scaled versions because it does matter. And it's done. And here x test scale and y test and y bread, and we get a score of 93%. So as you can see, scaling increases the algorithm's performance massively. But now let's take a look at how to get it done with the grid search algorithm. 93% is actually a pretty good score. So if you might not have to do this on the SVC algorithm, but let's say that you do. Let's say that you have an algorithm that's performing very low. It's giving you a score of, let's say, 60%. You could use the same performance tricks that I've used right now, and you could get a better result. But just make sure that when you are, after you have trained the data on a scaled data set, the next time when you make predictions, you have to scale that data as well. So just make sure that you're doing that. And now that that's done, we have the parameter, and let's just change some few parameters so that it uses our maximum CPU capabilities. Now sklearn provides us with some of the functionalities that allows us to use the maximum CPU capabilities. If you want to take a look at that, just type shift space in any method. Inside any method, we will be using the CV and the njobs method. So what do they do? If you want to take a look at what any of these do, they have the doc string with them. Just take a look at CV. It means cross validation generator. So it will create 10 buckets of the data to create the validation data. So we could use that. We don't have to use it if you don't want to. The main one that I am interested in the end is the njobs one. The njobs method, njobs would allow us to use the all the processing power that our computer has to offer. So if it's a multi-core processor, we will use all the cores. So for that, let's try n underscore jobs, set it to -1, so it will use all the processing power that's available on our PC. If you know how many cores that you have, or if you don't want to use all the cores, just the cores that you have, like you have 4 cores and you only want to use 3 or 2 of them, then you can use n jobs equals to and set it to the number of cores that you have. So now that that's done, let's just try it out. Grid search CV dot, and as we've already used before, we will be using the fit method. Let me just use the fit method. I will pass in the scaled data, TRAIN. Training data is passed, and believe I have to pass in y train. And now it's run off again, and let's see if it works. And as you can see, it works in a couple of milliseconds actually. So you can see scaling of data actually increases the or decreases the computational complexity. So now that the data set is scaled and we have used all the possible combinations, let's take a look at the score that we are getting. Oh, I'm sorry, it's not a grid search. And we're getting 90.33. So it's actually a pretty good score. The reason why we're getting different scores is because the number of times there's a lot of randomness involved in our data set. So if you train it multiple times, you get different accuracies. But as you can see, we're getting a score around 90%. Now, if you want to take a look at what the parameters that they use, you could use the best params method. So not the method, but the property. So C was 10, gamma was 0.5, and kernel was RBF. So we're getting quite close to what we already had. And the C was 1, kernel was RBF. And yeah, so these are the methods that we use, and we're getting a score of 90.3%, which is quite good. Now let's take a look at what happens when we use the random search CV. So if you want to use the random search algorithm, firstly you will have to import it, and importing it is not that difficult. It's in the same package that we already have. Import grid search from, you just have to type in random search CV, run it again. Now using random search CV and grid search CV are quite similar because we'll be using the same, almost the same things. So we have the same parameters that we'll be using. We'll be using the support vector classifier as well, and we'll be using the scaled data. So it would be quite similar. So in order to not make mistakes, I'll just copy it, paste it. I'll type in RDM or search CV. Now that that algorithm is done, let me take a look at randomized search. That's what I was wondering. So let's name it randomized search. Again, I'll be passing in a fresh instance of SVC. The parameter grid is the param grid. This is the grid that we created earlier with all the possible parameters that we'll be setting. And inside this one, we need to change it from param grid to param distribution. So because these are different methods and we won't be using a grid, we have to change it to param distribution, and we'll be passing in the grid that we created earlier. It will take a look at this and choose randomized random parameters and figure out the best one that you have to use. Now that that's done, we probably could get away with not passing in accuracy, so it will use accuracy by default. And this is done. Now let's random search CV and we fit it. We use the scaled data and we pass in, and as you can see it ran actually quite faster than the grid search example that we had. And now that grid search is done, we will be using the same attributes, and we'll be checking a look checking how much it improved our performance. So we'll be taking a look at random search best score and best params. So let's take a look at that. So random search CV best score, and as I said that it will take somewhere around the best score even without trying all the possible combinations. The best score we got was around 90%, and we got around 89.66%. So as you can see, that works. Random search CV, and we take a look at the best and RBF and gamma and C. So just the gamma parameter was set a little differently, otherwise it shows RBF and C exactly the same as the grid search parameter. And there's not a lot of difference between the gamma that's chosen by the random search and the gamma that was chosen by the grid search. So as you can see, both of them are giving us the right answers, and we are getting the right answers, and we are getting an accuracy of around 90%. So in conclusion, you should use the scale the data to get better answers. Just make sure that when you scale the data, you understand that you are scaling it, and the data that you get from any other source for prediction in the future, you would have to scale the data again. So if you use unscaled data in your production environment, then that would give you incorrect results. So even with 90% accuracy, you will be giving it the wrong data and you'll be getting the wrong answers. So with that in mind, we had how much? 93% of accuracy. Now I'm sure you're wondering, why did we get 90% here and 93 there? So let's again just run it again. I'm running all the parameters again. Earlier we got 93% of accuracy. Now let's take a look at this. We got 92. Let's run it again. So I create a new support vector classifier, fit it again, split the data, train it, make predictions, and 92%. So we get around 90% of the accuracy. You can see again we get 93%. So there's a lot of randomness that's involved here, and when you get some accuracy score from the data set, it's not going to be set in stone. It's going to take some time, and when it does, it'll give you different results. So when you run the random search algorithm again, or the grid search algorithm again, you'll get different results. Let's take a look at that. So as you can see, now you're getting 91% of score, and the estimators are this. So if you wish to use the random search or grid search algorithm, do know that there's a lot of randomness involved, and as you can see, kernel, RBF, and gamma are 0.2, and we are getting a good result. So the accuracy that you'll be getting is going to be around 90%. Scale your data, pre-process it, make sure it's easy to digest by the computer, and make sure that you are using the correct tool for the correct job. If you have a lot of data, don't use grid search because it's going to take a lot of time, even with the scale data. And if you have you use the randomized search, you could probably get away with it using smaller data sets. For larger data sets, random search is quite good. You could get the same, around the same accuracy score, and you would get it much faster. So with that in mind, the session has come to an end.
Just a quick info guys, if you want to become a certified professional in Python for data science, Intellipaat offers a complete course in the same, which covers all the major concepts. Don't forget to check out the link in the description box below. We hope this video was helpful to you. If you have any further queries, let us know in the comment section below. We'll be more than happy to help you. Thank you so much for watching this video. See you again.